Hello friends, welcome back to my channel. Today's class is going to be about coefficients, like terms, and constants. So if you guys have any questions about the content I teach in today's video, please make sure you let me know in the comments below or on one of my social media. I put my Instagram up here and my Twitter up here. I'll try and update you guys on there when I post. So yeah, without further ado, let's just get on with the video. Let's go. The topics we're going to be covering in today's video are coefficients, like terms, and how to combine them, and constants. So here we have a couple of definitions. So the first is a coefficient. A coefficient is a number multiplied by a variable in a term. The number is the coefficient of the variable. I actually do have a whole video about variables that I made quite a few months ago, so go check that out. I will link it in the iCard above as well as the description down below. Make sure to go check that out because it'll be pretty helpful to know. As you guys can see here, the expression I have is negative x plus 3y squared. Yeah, here 3 is the coefficient because it is the number that is being, multiplied by the variable. In here, you guys may see a negative x and you guys may think, oh, it doesn't have a coefficient. But that is actually not true. Most expressions like these, it's like impossible for it to not have a coefficient because in this case, it would actually be negative 1x. So you could just take the negative off and it would still be 1x, but you add the minus on and it's a negative 1x because there's not really a point. It's kind of like when you multiply a number and 1, it's always going to be that self. That's kind of the case here. Just remember that if you just see a variable by itself, then that usually means that there's going to be a 1 in front of it. It's just hidden, Next, we're going to like terms. So like terms are terms that have the same variable raised to the same power. So here we can see 4x squared plus 2 minus x squared plus 3x. In this case, 2 and 3x are not raised to the same power, but 4x squared and x squared are raised to the same power. They're raised to the power of 2. Now, it would be a different story if it was 4x squared plus 2 minus y squared plus 3x, because then you cannot combine them using addition and subtraction. That's why I said terms that have the same variable, meaning the same letter, raised to the same power. And that's also why you cannot combine 3x with these two. Not because of the coefficient, because it does not matter what the coefficient is. If it has the same variable raised to the same power, you're going to be able to combine it. In this case, 3x is raised to the power of 1. Just once again, we don't write raised to the power of 1. You don't really write 5 raised to the power of 1 because it's just 5. That's the deal with that. So here, 4x squared and x squared are raised to the power of 2, meaning you can combine them using addition, or in this case, subtraction. So you would technically be able to subtract x from 4x. So you would just get 3x squared plus 3x plus 2. And then finally, we have constants, and these are terms with no variables. So here we have negative 5x plus 2. So here, 2 is the constant, but 5x is not a constant. Negative 5 is a coefficient because it's attached to this variable. However, it's not a constant because it's still attached to the variable, meaning it's not a constant and it's not by itself. In this case, 2 is the constant because it has no variables. It's not attached to x, y, or z or any other letter. They're just numbers. Could be any number, but it can't have a variable attached to it or else it's not a constant. So the next part of our lesson is we will be combining like terms. So you can combine like terms and you can also add and subtract like terms. However, if two terms are not like, then they cannot be combined with using addition and subtraction. They can be, however, combined with multiplication or division, but that's not something you really learn in Algebra 1, at least not from my school. So we're not going to worry about that right now. It'll come later in your school life, probably sometime in high school. And even if it does come in like Algebra 1, it's not usually something you're going to focus a lot on. You're going to use addition and subtraction of like terms a lot more than multiplication and division. But then again, that's just from my school and my experience. So it could be different for you, and you might have to learn that, but I'm not going to be teaching that right now. So here we have an example, and this is 9x plus 3 minus 6x plus 2 plus 4x cubed, or to the third power. So I tried to color code it. So the constants will be in green. The factors that have an x, that have x raised to the first power or just x, are going to be yellow, and x cubed or x third power is going to be blue. So here you can combine 9x and 6x. So here you subtract 6x from 9x, so you get 3x because you subtract, in this case, the coefficient, not the variable. So the x's don't just cancel out because that's not how it works. You subtract or add the coefficient and just leave the x. I will talk about in a later video what happens if you have to multiply these two, but not now. Here, we are not going to add the constants, 3 and 2. And what do 3 and 2 make? 5. So you just get 5, no variable attached, or else it's not going to be a constant. And finally, we have 4x cubed, and that has no other like terms. As you can see, it's by itself. So it's going to stay the same as 4x cubed. Now, another part of combining like terms is being able to rewrite them in order. So you cannot just leave it as 3x plus 5 plus 4x cubed because that's completely out of order. You have to go from the biggest exponent rate that the variable is raised to, and then go finish with the constant. You always finish with the constant because it doesn't really have a variable, meaning it's going to go at the last. So in this case, you would rewrite it as 4x cubed plus 3x plus 5, because 4x is raised to the third power, followed by 3x, which is raised to the first power, and just 5. Yeah, you can always just tell by the number of the exponent, because, 3 is bigger than 1, so this means this goes first, and then this, and then this. So you wouldn't write it as 3x plus 4x cubed plus 5, because while the 5 is in the right place, you switched these two, and that's not correct. So now I have prepared 2 examples, which will hopefully prepare you guys a little bit for the advanced room. So yeah, I'm just going to go through them, how you do this. So in this case, you have 10x plus 5x squared minus 7 minus x squared. So here you have one factor that is raised to the first power, and that's 10x. Now you have one constant, which is just 7. And now the biggest variable is 2x squared. So you have 5x squared and x squared. So while you cannot do anything with the 10x and the 7, you can, in this case, subtract the 2 x squared values. So 5x squared minus x squared, 5 minus 1, because once again, no coefficient is the same as just 1. So yeah, here you would do 5 minus 1, which is 4x squared, plus 10x minus 7. This is how you would rewrite it. Here, we have a bit of a longer problem, but I promise it's not hard. It's fun once you get it. So here we have 9 plus 3x minus 6 plus 5x squared minus 2x. Now, In the last problem, the constants and the x values that were raised to the first power just had one of each, and the x squared values had two. But in this case, we have two constants, which are 9 and 6. We have two x to the first power values, which are 3x and 2x. And we only have one x squared value, which is 5x squared. So you would combine these. 9 minus 6 is 3. 3x minus 2x, which is the same thing as 3 minus 2, is equal to x. Because remember, you do not write 1x or negative 1x. And finally, we just have plain old 5x squared. You do have to rewrite it. You cannot just leave it like this. I'm not totally sure if you'll get marked wrong for it, but I'm pretty sure you would probably get like a point off for it. So definitely always just rewrite it. Greatest to least order. So yeah, you would write it like this because this is the greatest exponent, and then this is the variable. It's just raised to the first power, and then you have the constant. So that is it for the lesson, and now we will be moving into the advanced room. Let's go. Wow, so welcome into the advanced room, the first advanced room of 2021. Here, you just have to combine the like terms in this expression. It may look like a lot because there's a lot of terms, but it's just simple addition, subtraction, done. Not even multiplication or division. So here, we have 10x cubed plus 8 minus 7x minus 3x squared minus 8x cubed minus 1. This is a bit, new to you guys, but I promise it'll be easy. But for now, I'll give you guys 5 seconds. And of course, pause the video if you guys need more time, because if you guys are beginners, you guys are going to need a lot more than 5 seconds. 5 seconds. Done. So here, the first thing I like to do is look for the exponent with the highest number. So here, in this case, it's 3. So it's cubed. There's two values with that, which is 10x cubed and 8x cubed. And then look for the second highest, which in this case is just x squared. And there's only one value that has a squared, and that's 3x squared. And then look for the next one, which is just x. Once again, there's only one, which is 7x. And finally, make your way to the constants, which is just 1 and 8. From here, you can combine them. 10x cubed minus 8x cubed. Subtract 10 and 8, and you get 2x cubed. Next, you just have one of the x squared values, which is just 3x cubed, and then you subtract that, and then you have one of the regular x terms, so you will put negative 7x, and finally you have two constants, 8 and 1, so you do 8 minus 1, which gives you 7. So yeah, this is how you would combine the like terms in this problem and, rewrite it and stuff like that. So yeah, hopefully it wasn't too hard. If it was, of course, rewind the video, rewatch as many times as you need. But we have 3 more questions, so we're going to go on to the second one. So for number 2, we have basically the same problem, but with different terms. It'll probably take a little bit faster time. This one is 7x cubed plus 2 plus x plus 4x. So yeah, I'll give you guys another 5 seconds to solve this. Done. So for this one, look for the highest variable exponent. In this case, once again, it's 3. 7x cubed. Next, you look for the second highest. In this case, it's just x, or x to the first power. And there's two of them, which is x and then 4x. Remember, x, or just regular x with no coefficient, no number, is technically 1. In this case, it's adding, so it's going to be a positive 1, not a negative 1. And finally, we're going to look for the constant, and in this case, it's just 2. So now you would rewrite this as 7x cubed, because there's no other cubed variables, so you can just leave it alone, don't do anything to it. Next, you can move on to these terms. You can add these, so basically you just do 1 plus 4 because no coefficient equals 1. And then that's obviously going to give you 5x, because 4 plus 1 is 5. And finally, you got the constant, which is just 2, because you left it alone. Now we're going to move on to the third question. This seems to be about a medium difficulty, but it should be just as easy as the other two. 13 plus 6x minus 8 plus 9x squared minus x. So I'll give you guys another 5 seconds to solve this. Done. So for this one, look for the highest variable number. In this case, it's just squared, which is 2. So yeah, there's only one of them, so you can just leave it alone. Next, you can look for the second highest, which in this case is just x to the first power. So you can combine 6x and x. And finally, look for the constants. In this case, it's 13 and 8. So to combine them, because you only have one squared value, you can just leave it alone, don't do anything to it. Now, moving on to the yellow terms, you can combine 6x and x, and in this case it's going to be minus. So once again, 6 minus 1 is 5. So you will get 5x. And finally the constant 13 and 8, you minus 13 and 8. So that is another 5. So yeah. Hopefully that was also pretty easy, and now we will be moving on to the last question. So yeah, here is the last question. This one is a little bit different, and it should be easier, just a little bit of like a cool off. But if you guys need to, then rewatch like the lesson and redo the advanced theorem and, you know, get some practice. So yeah, here, this is just a little bit easier, and you just have to list the like terms, but don't combine them. But it's not like you can, spoiler alert. So just like put the x squared value here, the x value here, and the constants here. I'll give you guys 5 seconds to do that. So all you have to do is just look at, you know, the variable, and if it has a variable, first of all, and the power is raised to. So x squared is the biggest, and in this case, it's 7x squared is the x squared value. It's the only one. So you put it like this. So now we're going to move on to the x value. In this case, it's just 13x because it's the only one that's raised to the first power, or just doesn't have, like, you know, there's no visible variable, but technically it's still there. So yeah, we're just going to write 13x. And finally, we have the constants, which is just plain old 5. So yeah, that was it for the advanced theorem, and hopefully you guys really, like, you know, you guys did well. Hopefully it was a little bit easier for you guys. If it wasn't, you know, that's totally okay, because everyone needs time to improve, and, you know, just take your time, rewatch the video as many times as you need. Thank you guys so much for watching this video. I really hope you guys enjoyed it, and if you did, make sure to definitely give the video a thumbs up, subscribe to my channel, and hit the notification bell so when I upload, you guys will get a new notification, and you guys can just click on the video and watch it. Speaking of subscribers, thank you guys. I recently hit 21 subscribers, which is over 20. I would just really like to thank all of you guys for sticking with me throughout this journey. You know, it was a rough year in 2020. But now I'm so motivated, keep creating content for you guys, and are happy to see me back and start doing more math lessons. I apologize for the break I had to take, but I'll see you next time. Bye!